Hey everyone, how's it going? This is Idan Aronson. Today I'm with Cheng Lou. 6 years ago, Cheng got out a talk that has incredibly influenced my career. Its name is On the Spectrum of Abstraction. And I am incredibly honored to host him today in our podcast. Hello, Cheng.
Hi, how's it going?
Amazing. How's it like in California right now?
It was hot in a few days before that, but now it's typical California weather. So pretty happy about that. Also, just to take an occasion for a plug, I've recently reached out on Twitter to see if anyone's interested in just having some dinners together and talk about engineering and all that. If anybody's interested, just private message. And I'll be happy to.
Yeah, you should all know I saw this tweet and I was so bummed out not to be in the Bay Area. So it sounds awesome. Cheng, I wanted to discuss a bit in length your talk on the Spectrum of Abstraction. It's, pun intended, a very powerful talk that not a lot of people are can get into the length of it, because into the depth of it, just because of the length, it's like pretty short. And I thought maybe we can dive into it a bit in depth to what was the motivation, like thoughts you had giving this talk.
Yeah. So that talk was actually cut twice already. It used to be much longer, but obviously it didn't fit into a conference talk. And when I pitched that talk to the organizers, they're like, wow, okay, we don't know what to think, but okay, let's just roll with it. So it's nice that they took a risk on me for this. That talk did have a very good motivation. The motivation for me has changed over years. I mean, over the last, I don't know how many years, I have grown as an engineer as well, but this has stayed rather consistent, I would say. I do think there's a better way to explain those things too, not through necessarily abstraction, but it was a nice hook for people to get into that topic in the first place. I used to work on React, on the React team at Facebook, and one of the most important tasks that I was given was to refactor the entire Facebook monorepo, which was basically a single giant repository back then, in order to upgrade our React APIs, right? There's a breaking change, and you first have to make sure that internally it works out before you release it into open source, both because, at the end of the day, you have to ship it. And also because you do want to test it internally first to see it actually works out before it goes into the wider open source where you can't really control the ramifications anymore. So basically, I coded a lot of code, like a high 6-digit number of lines. And I came back with some extremely different conclusions than what people in the industry might think of in terms of what actually constitutes code that actually works. What is code that is working in certain circumstances and not the other, and vice versa. The predominant impression I've gotten is one that where people write too much abstraction. Too many abstractions. There are way too many indirections, and there's all sorts of intent to future-proof code that actually don't work out, that someone like me had to dig into and make them actually work against a future version of the API and all of that. So there's no way I could possibly convey all of that nuances just like that. Maybe in a series of 10, 20 blog posts, maybe we can capture that, but I have a 50-minute or so. So basically, I gave that talk in order to give some people a tool to start thinking about these matters, knowing that, like I said at the end of the talk, this is a talk that's basically useless if you don't think about it and apply it, right? I'm not giving you a fish; I'm giving you a fishing rod.
Right.
So that was the motivation to begin with. There are some concrete details we can also discuss on. But yeah, that was the gist of it.
So just to give the audience a gist of it, what in your talk, what do you mean by abstraction? Like abstractly? And yeah.
Even this is basically very hard to define, because if you ask the theory people, they will have a proper definition of it, right? But I wasn't aiming for that necessarily. I was just aiming for like this general idea of like, oh, someone tries to take that piece of code and reuse it in multiple places for different circumstances, maybe bundle it into a library. So as long as we kind of informally agree with it, I can also start with that informal definition and work out something for you. But of course, if you define it more clearly, precisely, maybe it's not as applicable anymore. But yeah. So again, my definition is just that vague thing, like people extract the code to make an interface, or maybe for reuse or whatever. To be clear, these are actually decoupled things that we couple them together due to various real-world engineering needs. So, for example, if you just want to spare writing 1 or 2 lines of code and you put it into like a reusable function, technically it's not really an abstraction. It's just like a form of reuse, really, right? Abstraction kind of entails a little bit more about like hiding the right nuances, exposing the right structure and all that. But for regular engineering, I thought that was good enough.
So for me, after watching the talk, I think the concept that really stuck with me is how to write better interfaces, how to write better libraries in general. Like, what is one principle you can follow to design software in a better way?
Yeah, well, by the definition of the talk, there's no single principle, and I think it's actually, I think if we chase that single principle, things go wrong very quickly. Because either we find the real true principle, which is it depends, right? Or we find one principle we believe a lot in, and we try really hard to shoehorn it, and then make some of these use cases kind of much worse. And at the end, these use cases inevitably bite us back because, I'll give you an easy example, right? You stick to this principle you believe a lot in, and you apply it to 100% of code base, but that 1% of code base does not abide by it, and that turns out to be the hot path in your app, right? Because there's a match between the compile time and runtime thing, right? And now your entire app is actually, which was dependent on that part, is not working out, even though for you, statically, seems like 99% of the time, like this principle holds true. And I think that's a mistake people make a lot in the industry too.
Right. So without like giving strong principles on like how you should or shouldn't write software, after refactoring so much code in the code base, what was the like thoughts, like the raw thoughts you had? Like what was what conclusions did you?
Well, the conclusion was that it depends, but I'll get more into the details on what it means for it to be it depends. I've seen patterns that actually work out in practice that make my life much easier. I've seen patterns that don't work out and make my life much harder. And I've seen patterns that make these users' life much easier at the expense of mine. So there is a trade-off there, right? So if you're an infra engineer, you adopt a certain perspective, and your goal is, even though you say it's for developer experience and all that, your goal is almost always your own developer experience at the expense of maybe a user-lens developer experience, really. People do try to aim for various such goals, but yeah. And truly it depends, because some of these patterns, you can clearly see that they help them kickstart this entire endeavor, whatever the sub project is, right? These patterns are extremely crucial early on in the life cycle of a product, and later on you need a senior guiding hand to say, now we need to gradually, incrementally move away from that pattern, but they are absolutely needed. And there are patterns that are, absolutely needed when your team grows from 2 people to 10, 20, that you should not reach for when you're a team of 1 or 2, right?
Right.
And we've seen, I've personally seen the Murphy's Law in action, which is that people will pick the worst possible thing at the worst possible moment at scale, which is like you have some kind of so-called senior engineers using patterns that they are familiar with because they're more of a 1 to 10 people instead of 0 to 1 person. They use these kind of like a quote unquote scalable pattern on a project, and the project dies and they don't even know about it. I know about it because I see dead code, half dead code there. And I was like, that could have been a thing, right? And that was a shock to me. And I've also seen some of these very nice, very tight patterns live beyond their welcome, where you're like, well, you absolutely needed that, but right now it's just a pain in the ass, not just for me, but also for the people who refactor that code. And you definitely see more of the former. And I am reminded of a quote by I don't know who, but they say, well, if you make your code simple and easy to swap out and clean and all that, then over time in the code base, well, since they're easy to swap out, they get swapped out. And in a long living code base, all you have is code that's hard to read, hard to refactor and modify. And so a code base inevitably follows that Murphy's Law and gets worse over time.
So just to make this more concrete for our audience, what when you say patterns, what kind of patterns do you mean? Like, for example, for a very big team to use something that a small team would use, or otherwise?
There are several of them. So again, it depends. But one of them is when to drag in dependencies, when to take on a dependency, and when to move away from it. And I've seen both sides of the story where a team drags in the dependency early on because I really don't care about this. I just want something that solves this use case already, and they use that. And over time, they're as the product changes, as they pivot, as a designer or the product manager ask for things, that dependency becomes basically calcify their architecture, and it rots and it's bad, blah blah blah. And they have a hard time moving away from it because at the very foundational layer, there are some ties to that particular library. I've also seen the other way around, where they did not take on a library. They decided to do it themselves, and they overestimate the complexity. They underestimate the complexity of what that library was actually solving. So they end up moving slower, right? Where they moved faster. I've also seen the other side of it, where later on someone, because it's 2 axes, right? So you have 4 possible quadrants. So where I've also seen where later on people adopt a library and things work out for the better and worse. And I've also seen the reverse, where they unadopt a library and things work out for the better or worse. But again, it depends on the library. There's no rule, right? Because the library can be good or bad. It depends on that, and it depends on your use case. And if they don't match, then you get a bad situation.
Yeah.
So truly, and the only thing I can say is, like you need a engineer who knows what he or she is doing, and knows about these kind of circumstances, and be like water, like Bruce Lee says, right? Like when the circumstance change, you reevaluate your opinion. You don't stay too stubborn about some of the things, but in some other things, you stand your ground firm and say, this will work out because I've been here before. It depends, but honestly, it's just experience. And I'm also reminded of someone on Twitter who once said that until today, software engineering is more like a craft. And more like we need more of an apprenticeship model, because all these nuances, they are not formalized yet. We don't have time to formalize them, and we maybe should not be formalizing them because they change too fast, and you don't want to be calcified with a certain formalization of it. So yeah, and for the audience, I think for the juniors especially, the biggest advice I can give is just go sit with the people who know what they're talking about. If the people are showing results, sit with them and ask them questions, you'll be very surprised at some of the conclusion they give you.
Right. These principles of like when to use a function or when to not, like when to abstract or when to not, depends on experience and boils down to. So you talked about two forces, which is very interesting for me. One is the infra developer that aims for like it would be easier for them, and it's interesting for me what does it mean easier for them. And on the other hand, in the talk you talk about engineers aim for things to be concrete, which is I guess simple for them. So
well, it depends. It depends. But to answer to your first question, infra engineer kind of prefers, in general, right? Most infra engineers prefer that kind of uniformity, right? Because for them, they can touch one thing and know that it generalizes into 10 things, right? Mm-hmm. So they tend to make these kind of high level decisions top down and not give necessarily too much wiggle room, and because it's easier to refactor, and it's truly easy for them if they do have a holistic picture to move from one state of the repo to another. If they don't have to cater to every specific use case that might violate some assumptions or whatever, right? So basically, another way of saying it is they establish the invariance, they establish the skeleton, and they let you do the rest, right? And product engineer does most of the time the other way around. So that is easy, but the thing is now you don't know what your product needs, and so one thing that's missing, two things that are missing in this entire topic is what does a designer think? Where's the UX and UI in all of this? It seems like we don't talk about this at all, right? Which is a pain point in this whole discussion. And the even more important thing is, are you even building the right thing? Nobody talks about that, right? This is actually, I'm not being petty, actually. I'm not, these are not orthogonal concerns. The import is not orthogonal to your product. It's not. Because we do know for a fact that we are all subject to Conway's law, right? Conway's law, which says like you will ship what your organization chart looks like, right? And so, because at the higher level, the bottleneck is not in the little nitty-gritty engineering. It's in the communication between organizations. So your architecture will reflect that, right? It's like a gas that fills like a weird sort of container, and because you're subject to Conway's law, the reverse is true. Where if early on during the life cycle of a company, the engineer established a certain way of doing things, then people will gravitate toward that, and your organization will also look a little bit different too. Mm-hmm. So these are not orthogonal concerns. So you have to, like Steve Jobs used to say, you have to start with the product and work backward. That will determine everything, including the code you write on a daily basis. So if an engineer has too much of a good time, then the product people are suffering. Yeah, the concrete engineers are suffering too. The product engineer, the designer might be suffering too. If a product engineer has too much of a good time, then probably the infra engineers are suffering too. Maybe for a good cause, right? So ultimately, one of the conclusions I took away from that particular experience, among many that I have on React and subsequently on Messenger and all the ReScript and all the other projects, is that sometimes it's okay for me to have a painful experience refactoring some of these things. It's worth it, right? And I would almost say that the ability to bear through these pain is maybe a hallmark of a senior engineer, because sometimes there's a piece of code that is painful, and it takes a tremendous amount of courage to say, I should not be touching that, right? I should not be trying to make that good, because people don't realize that it's a budget. This is another big topic that we might or might not have time to delve into, but people think that beautiful code will give you a beautiful product. When in reality, it's actually a budget. You have a certain amount of budget you can spend either on the product or the code, and you need to allocate them very carefully. Some of the beauty on the code will reflect in the product. Some of them absolutely will take away your time to work on a product, and vice versa. So you have to be very careful about that. And so if a startup's code is too pretty, usually they're not shipping something that's very ambitious, and vice versa. That's not always true, but that is because this kind of Murphy's Law happens so often. I feel compelled to point this out so that people are more aware of it.
I definitely second that. So what I see a lot of the times is great startup engineers would be like, we need to build the product. Like the minimum, the straight to the point way that's the product going to behave as our metric says it should, or our product people says it should, someone along this chain. On the other hand, bad startup engineers would usually like create all those abstractions, all those like utilities and helpful, and like thinking infrastructure when really they should ship. And on the other, and the same like vice versa, like engineers that work in large corporations, if they can't think more broadly about a problem and abstract away a few of the core problems of their organizations, their product engineers are going to just re-implement again and again the same business logic.
Yep. So it depends, right? And I've seen, just so that we're clear on the last case, I've seen that actually happen quite a few times throughout my career. And I've also seen that work out for the better sometimes. So that's why ultimately my only advice is it depends. Because sometimes it's truly like engineering is like that book, Innovator's Dilemma, which I recommend most people to read, even though it's not about just engineering. It is about engineering too, where sometimes you just have to let 1,000 flowers bloom. And sometimes it's not like in basketball where if you miss, it counts as a miss, right? Sometimes it's more like in baseball, like Alan King says, where if you miss, it's just part of the game and you're waiting for that one strike, right? So what game are you playing? Well, you have to first determine that before the infra engineer says, let's just squash all possibilities, or let's just let 1,000 flowers bloom. It really depends on what you're making. And yeah,
that's yeah. But one guiding principle you were mentioning in the talk was the concept of the least power. And I would love you to like explain that a bit to the audience.
So I think people would also sometimes disagree with that, with counter examples and all that. But in general, I think that holds somewhat true. When I say least power, I don't mean literally let's just do the least amount of things. I mean give it a little bit of wiggle room, right? But people usually understand that. The real point behind this entire talk was about entropy control. It wasn't actually about whether you should reuse some piece of code, which whatever. It's about how do you control the entropy of a code base. So we're basically explorer of a multi-dimensional space, right? You could call it a desert if you think that's a boring space to explore or something. And the point is not to get lost, but the point is also to find treasures along the way, and depending on what you need. When I mentioned principle of least power, it's a counter reaction against people who expose too much power. It's a problem in the open source community too, actually. But it basically means you didn't actually solve the problem, right? Because ultimately, I could expose all the power through assembly, and what have we gotten? Nothing, right? So and sometimes people think they are exposing too much power when in reality they're exposing too little, because power is not also single dimensional. I squash onto a single dimension in my talk in order to convey a point, but but in reality, it has a wide amount of dimensions. And some engineers, when they make an architecture, they think you can do anything now. But actually, you can do anything within that space, and you can do nothing if you try to do something differently, right?
Mm-hmm.
And so it's truly, it depends again. But least power is about entropy control. It's about making sure that the chaos doesn't dominate you. It's about you leaving a little bit of room to your code, little bit of breathing room to iterate, but also not too much.
So for me, let me see if I get it straight. One example I can think of is SQL. So in SQL, you're pretty limited, right? It's more declarative. You kind of say select, where. You don't say you don't use for loops. You don't access indices. You don't do all those kind of stuff, but rather you declare what you want the code to do, the engine to do. And then there's a whole engine that figures out how to translate these higher level language into actual steps, which is called the query planner.
Yeah.
And in this kind of scenario, like the principle of giving less power in this context is like for loops or functions or whatever, is I give the query planner more room to optimize my query if it's possible.
Yeah, but I'm glad you mentioned that example, because maybe we can use that as a concrete thing to talk about. There are many things happening in this such that you get to have something like SQL giving you those benefits that you mentioned. They are not all the same. Sometimes they will go against each other. So I would like to dissect it a little bit. Right? So first thing is, if you're a genius engineer, you don't need SQL. Mm-hmm. I'm not saying that to be petty. I'm saying that to establish like two extremes so that we can interpolate in between, right? To get a good idea of the space we're talking about. So there is that force here. If you know what you're doing, you don't actually need SQL. And actually, lots of time people don't realize you don't even need a database. But yes, most of the time you do for like a typical business sense and all that, right? But that particular engineer will know the memory layout of the data properly and say, well, we're going to cater to that case, and then we can have a very short path. And you don't even need file; you just write to that memory, like whatever. But the thing is, that doesn't scale in terms of people. So SQL found that sweet spot where it gave you just enough to shoot yourself in the foot, but not too much so that if you onboard an engineer, they'll just make a mess in terms of maintainability, in terms of performance and all that. So by giving you that declarative query, engineer lesser than that genius engineer will be able to write relatively fast code. Yeah. But if they learn properly, they will write code that might be faster than SQL. Who knows? So there is that, first of all. And that is in the fuzzy domain of ergonomics, of UX and all these things. And also in the entropy control in the larger sense, like what if we have engineering of various level. The other thing that is not necessarily coupled to that particular point is that those restrictions unlocked invariance for SQL. Invariance being, I have a table. I mean, it's easy to say that, but we have a specific format for our data, so I can massage it in a way that is friendly to the CPU, to the memory layout, to whatever machine, right? You don't get to say, for example, it is not a graph database, right? And it is not also a loose collection of tags. It is table. And so once you unlock this invariant, you get to use some form of algebra over it, some form of optimization, knowing that you can do batch processing, right? Parallelization, indexing, right? Sorting even, right? Sorting, assuming that you have an order between things. But if you don't have that invariant, you can't sort. And if you can't sort, you can't have indices. If you don't have indices, you can't have performant databases, blah, blah, blah. And if you don't have these indices, you don't have a performant database, etc. This might not be always be true, because I've seen cases where people think that that they can just impose random arbitrary restrictions that don't actually pay for their worth. And ultimately, the product gets way slower because it turns out someone needs to circumvent it anyway, right? And even in SQL, this is in a big corporation. This is the case sometimes where SQL is not enough anymore. Bam! You bring a whole like middleware layer, right? Like to basically control that and generate those SQL queries. And it turns out your performance problem is all in that layer now, right? And so at that point, did SQL really do the job? Well, you might say yes for the majority of people, not for these people. But then if you evaluate holistically at a company level, then maybe not. So it depends on the perspective you take, right? You can zoom in and say, I did this job, but then there's this vast amount of crap that doesn't actually did its job properly. So I wouldn't say that. I would say that SQL being quote unquote declarative, for whatever people's modern definition of that is, usually means convenient. But I wouldn't say SQL's declarativeness is. I would say it's a sweet spot that unlocks many of these benefits, but you have to be careful in understanding what you actually unlock on the social level and the engineering level, etc.
Right. So, for example, in your past project, React Motion, which was, when you gave that talk, was pretty popular. Did you also apply these ideas to it as well?
Okay, so first, a pragmatic note about React Motion is that you should probably not be using it anymore because it supports only an older version of React. I think I haven't used it, but apparently people like React Spring, so maybe you should check that out and all that, or whatever else. Animation is a huge domain. We won't be able to properly talk about here, but I would just say that my concern about React Motion is like none of what we're talking about in terms of abstraction matter for React Motion. There's this very important law that I think people, especially engineers, should follow more, which is Omdaw's law, which is about parallel versus serial performance. But really, it's about where the bottleneck is, right? If something you're solving is only 20% of the bottleneck, if you do a perfect job, you will erase that, but you will still have 80% of that remaining problem, right? Whereas if you do a crappy job at that 80%, you solve 50% of it, then you still get 40% benefit. So anything that we're talking about in terms of engineering does not matter to React Motion. What matters to React Motion was that I was setting kind of a tone in terms of we should have that in React, and we should make sure that React can satisfy that. If we have to contort React and something is wrong, then React has to change. Because this is what you want at the end of the day. This is not something that should be contorted into React. By what you want, I mean like tasteful, mature animation. I know like people do all sorts of crazy animation stuff too, but that's only because the discussion level of these kind of interactivity is still so low in this industry, really. But ultimately, you do want to have interactivity, and sometimes React, at least early on, prevented that from happening. So yeah. And the other statement I wanted to make was to myself and also to the team too back then, where I remember saying to Jordan, like, we need to be able to support performance where we can actually re-render the whole tree, and because this was about latency. UI programming is like a soft real-time system. It's about latency, not throughput. Lots of people get that wrong nowadays, right? They think they can cache things and get a high throughput, but that just janks latency more. That just makes your worst case even worse. And now you're just dropping more frames, right? You start caching when you're out of options, but you try not to be out of option, right? It should not be the first thing you reach for. So React Motion was an excuse to say, I do have a good use case to ensure that React should be good latency-wise. And that message got completely lost. Because the whole point And people optimize around it, and they might say React Motion is slow because it re-renders the whole tree. And I'm like, that's the whole point. I want to show how slow the whole system is. Like, if you look at the game engine, they have no choice but to re-render everything, right? Well, sure, they do have different systems. They do have data structure in place to accelerate some of the calculations. But ultimately, if a character is standing in place, you don't get to say, hey, you need to be absolutely still because I need to optimize my code, and I can't do that if your character is moving around. I can't have your tree blowing in the wind because that's not good for performance. Well, then your performance is rotten, right? So I was taking that perspective and say, we need animation. Animation will force you to reconsider some of these architectural decisions around allocation, various computation needs inside React. And so hopefully that exercises a back pressure to React in order to make some of these things better. But unfortunately, that wasn't true. And ultimately, I think these kind of library got a sour end of the blame where they are being slow. And yeah, they are. But, I think, no, I can make it fast. I can just do the React Spring way, right? Or I can just use CSS animation instead of JavaScript one. But ultimately, I think the framework needed to cater to that better, and I'm not sure it necessarily did.
Tangling it back into the talk, you kind of wanted to create a situation like a product engineer that you say, I need more ability, I need more performance in that case.
Yeah,
from React.
It's a thorny thing to talk about. I think in this discussion, I think most of the audience won't even understand what the point. But and some people, some expert will come and tell me, well, that's not how it works. Like even in the best cases, you still have to upload that to your GPU, so you still have that. No, that's not true. If you look at the truly beautiful and great experiences on some of the best platforms in the world, for example, iOS, right? The best app built there are actually, they actually run animation on the main thread. Async Display Kit did that, right? And they actually reverted the entire scenario on you. Where at the beginning, it's like, oh yeah, I'm going to send my declarative snippet to core animation, let it execute an entirely different process because that's more efficient and all that. Quickly, they realized, I need these gestures to be interruptible. I need these layouts to change in real time to respond to what I'm doing. And I can't do that if I'm just sending declarative snippets all the time with like high cost, upfront cost, but low subsequent cost. I can't do that anymore. I have to make this fluid. And therefore, I'm going to reverse the entire situation where everything I care about should be on the main thread and everything I don't care about should be on the secondary thread. And what do we care about? Animation, fluidity, and all that. So they put all of that on the main thread. And so if you look at the companion library to Async Display Kit, which is called Texture nowadays, it's pop animation, right? Or was it called pop or something like that? And that thing is purely on the main thread. That thing is like a React Motion-like thing, except they were able to cater Async Display Kit / Texture to the library and ultimately build one of the best apps ever built on iOS, which is Facebook Paper. Yeah, and subsequently, Apple itself learned the lesson from these ex-Apple engineers and realized, I guess like that was a local maximum back in iOS 1.2.3 that we needed this model where you upload these things to GPU and not touch them and all that. Turns out we do need to touch them. So if you look at Springboard, which is actually made by some of the ex-Facebook Paper engineers, Springboard is completely interruptible, and it doesn't use any of these kind of animation, old senior animation thinking that you're used to. And so I don't know how this will go through to the crowd we're talking to, because talking about senior animation is even too much of a ask for people who think they can just put a localized CSS animation on a button, or not at all in the case of React or so. But yeah, that's basically I would say the spectrum of thinking that we should have maybe in 10 years.
Yeah, that's an amazing example, I think, of be like water. So iPhone 1 to 3, you couldn't just give people to run animations on the main thread.
Yeah,
iPhone 12, 13, you can.
But a lot of places in the system, they can't anymore because they they use that architecture. They say it's performant, and so they have uninterruptible gestures everywhere, except Springboard and Safari, because these people absolutely know what they're doing. And but the rest of the system, the other people too, it's just, I'm not saying they don't know what they're doing. It's just, it's a calcified system, and the system grew too big, so not one person can just be can just say, let's change that to be the other way around. To be clear, though, the way Texture did things, Async-to-Split did things, was very dangerous back then too. You need a team of excellent engineers to pull that off, and I don't even know if that's the right thing to do at a scale. But if anyone can do it, Apple should have been able to do it. Should have been able to expose that power and give you the right primitive for the newcomers too, and not have this compromise. So Alan Kay said it very well, where I'm paraphrasing him, but basically he said, when you design these API, you should make the harder things possible and the easy things easy. You should make the easy things easier at the expense of making the harder things impossible, right? Mm-hmm. Unless you explicitly did want to make these harder things impossible because you wanted to establish invariance, security, blah, blah, blah. But otherwise, you should not do that accidentally.
Yeah, it's a different thing to build logo and to build a full-blown programming language.
Yeah, basically.
Which brings me to a whole different subject that you've been a major contributor to, which is programming languages design, which is the most powerful, yet as the talk says, like the least useful thing, I guess, like to work on the most abstract level.
Yeah.
But I'm fascinated by the project of Reason for many years. And I kind of wanted to learn, how did you came to start it with the work on Messenger and yeah.
Well, first thing first, it's language is not the most powerful. There are way more powerful things, like there are the low-level stuff. And it's only the most powerful because right now hardware is something that people deem untouchable, which is not true back then, which is not true even at Apple, which adopted that Xerox model thanks to Alan Kay's advice and that Steve Jobs listened and all that. Well, and FPGA, I guess, was supposed to change that. I don't know what's going on there, but you definitely see that the most powerful is when Apple gets to release something like M1 and M2, right? So, and at this point, you're like, oh, I guess I don't care about language design. I just make the chip fast and everything else is fast. To be clear, you still have to cater the language to the chip, which they kind of did, but yeah. So language is somewhat of the most powerful if you assume you cannot touch even lower level, but most of the time you actually, sometimes you still actually can. Reason was not started by me, and I think I should give due credits. Reason was started by Jordan after React and React Native, right? I have nothing to do with the React Native. I just worked on core React for the web. Anyway, and also it is originally a fork of OCaml, and the bulk, right? If we're talking about Amzon's law and all that, the bulk of the work has been done by the OCaml folks over decades, and they did an excellent job of striking a sort of sweet spot that I would say academic people usually don't get to strike, which is that they actually care about real world use cases, which is rarer than you think. So I have a high amount of respect for that. And ultimately, when Reason became two things, or Reason for native stuff, and then for JavaScript compilation, we call it ReScript with its own toolchain, because it turns out we need to aggressively cater to JavaScript idiosyncrasy if we want it to be even good for a JavaScript crawl. That thing was mostly maintained the compiler level. It was mostly maintained by Bob Zhang, who is a compiler author who had made a heroic effort, a very, very shitty effort, but very heroic. Sorry, not shitty, but very hard decision. Right? Very hard, but in my opinion, right decision of forking OCaml earlier in its pipeline, right? It was hard on him as an infra engineer, like I said previously, but it was absolutely the right hardness to have, because we get to, as users, we get to benefit from his harder work. So yeah, and also, I need to give credit to all the people who actually did make that happen, not just me. Like Maxim did later syntax stuff. Cristiano also did lots of static analysis stuff, right? Jordan mentioned that again, the whole Camel community. Some people we did contract actually, so at least we're pouring that back into the community, sort of, and Ricky and all the other people who actually used to be on the team. But yeah, I was initially just a janitorial figure there. I was just like, I want to work on whatever Jordan's working on next. so I was like, can I please join that and do? But ultimately, after my React time, React's React Skip manager at that time was Tom Okino, and Tom was an engineer from Mutool turned manager who is excellent. And he gave me one of the more important advices in my career, which is, he said, I didn't really want you to do React anymore. If you want, you can come back to this team and we'll welcome you with open arms, but I want you to do products. And at that time, I was like, yeah, okay, I understand what that means. But understanding what it means is very different than truly feeling what he means, right? So I went to a product, which is Messenger, which I cared about, right? Going to make the chat work and all that, and those lessons are what completed my lesson from my refactoring days on React, right? Because during the refactoring days, I saw from the eye of an infra engineer what mess people make, and I thought I understood things, and I was like, oh, this is the right thing to do. But then on a single vertical product that is just beginning, you see a completely different set of lessons. Right, and then it validated some other of my infra thinking, which I talked about earlier, which is that, well, actually it depends. It depends on what stage of the product you're at, right, and what kind of guiding hand you want to give it. So on Messenger, I was just making things work, making UI UX back to the domain I started with when I did Flash when I was a little kid and playing with SVGs and all that. I enjoy that very much because ultimately I know this talk is primarily about infra and like these kind of pseudo philosophical thinking about engineering and all these things, but and programming language. But ultimately, like I just want to draw things with a computer, and I don't know why I ended up here, but here we are. And so on Messenger, it was. When I joined, it was a code base that's going ahead in full steam, but unfortunately, some parts are like collapsing a little bit. And I decided, well, maybe we can try Jordan's new thing on this. Right? So React truly became a thing when Pete Hunt put it on Instagram. I thought, hey, Reason also needed someone to dog food that, right? Because I actually, at that point, after all these experiences, even though I was still like a relatively green, I already no longer believe in like these pie in the sky architectures that don't validate themselves, right? And this is a recurring topic, and this is part of the things I also wanted to convey. If we want to tie back to the abstraction talk, where I wanted to ground engineers so that they can go backward, up, and validate whether their abstractions are valid or not. And they'll realize lots of time, way more than they think, they don't work out. So anyway, on Messenger, we just put Reason on it, and they actually worked surprisingly well. People were surprised, including Cristiano, who was on Infer before. Infer, which is an amazing project that people should talk about more, actually. But and then he got curious and he joined us, and it was fun. And it was not all fun because early on there is quite a bit of churn, especially regarding goals, regarding what Facebook needs, right? What Messenger needs, what the product needs, what the infra needs, and all that. And then my opinion is that we might have open sourced it a little bit too early. There are some good reasons why we had to do it that way, but I won't talk about them anymore. But ultimately, I did think it was open sourced a little bit too early. We lost control of it a little bit too soon, and before it went from a baby to a full-grown teenager or adult. Let's just say, but it did work on Messenger, and from what I understand, it still does. Which honestly, for a programming language that actually still work on the code base so many years later, I think I'm pretty happy about it. And people who do language know how hard it is, because it's very easy to make a language. It's very hard to make a language that has adoption, because that's a different game. That's politics, right? And so all in all, I'm rather proud of that piece of work. I'm not proud of the necessarily compared to how good we can make it, but I'm proud of just the mere fact that we actually shipped it.
But I think it talks miles that a language you designed ad hoc, like not ad hoc, but like on the way, made it to a product later, because they could have refactored it away.
Before that, I was a language enthusiast. I'm on Hacker News all the time, and I look at these languages. I've tried all of these languages out there. I tried, even the esoteric one that Haskell people will find esoteric. I tried like all these array languages too, and concatenative or whatever. But I was an enthusiast, but that's a very different perspective than, you have to sit down and ship products, right? Working on language truly makes you realize some of these trade-offs. Working with world-class people, right? Bob, Cristiano, Jordan, and all the rest, truly makes you realize all the trade-offs and truly makes you realize what simplicity actually should be, and how you can find a sweet spot that's also simple, performant, and also good for the end developer, blah, blah, blah. Mm-hmm. And it also makes you realize how different technically it should look if you want people to actually use it. Lots of language ideas, lots of them, and especially in the functional community. Back then it was the OO community, but nowadays it's the functional community. Lots of these ideas only work well and extremely well on their own. They do not work well when people try to use them. And I think there are lots of overly vested incentives to ignore the people factor in these kind of language design, because usually the makers of these languages, they just want to make their own language. It's like a toy train club, right? You don't want the whole world to watch you make toy trains. But if you do want the world to make you watch trains, then you have to build them differently. And so, yeah, I've learned a lot about human behaviors also during that thing, and also unfortunately, as a janitor, I have to clean up like some of the community related stuff. And I was like, wait, I didn't sign up for that. I didn't have expertise for that. Like, I was just there to draw computer graphics, right? But ultimately, I did learn along the way too. And there have been lots of churn during the process. But yeah, I came out a better person. Hopefully.
That's amazing. So you are there in the Messenger team working on the core product, right? The Messenger app. All while in helping to invent this new programming language and maintaining a community.
Yeah. And
how does that all fit together?
It basically didn't. It was extremely hard on me. The last few years have been actually to be honest, quite harsh. It was not always fun, but ultimately I have this burning passion of learning and making sure that things actually work in the real world and pretty things. And so I just kept going and all that. Maybe a little bit overboard from time to time, but ultimately it kind of worked. I don't know. I don't know if there's a general lesson about whether you should do it that way or not. I think it depends on the person. But fortunately, it's not like 3 jobs, right? It's like a 1.5 to 2-ish, right? Because there's quite a bit of shared synergy, I would say, between these things, right? Because some of the work I was doing on Reason was basically messenger infra work, right? And vice versa. And it if you look at it holistically, it did help Reason iterate faster in the right direction. We were about to commit early on some critical mistakes, and it's thankfully we got to basically pivot a little bit more early on, despite the fact that it was open source a little bit too early, and I didn't really have a say in that. We were still able to pivot a little bit. It wasn't good for the community early on, though, but I think that's what you get as an early adopter of things. But I think we still could have done a better job.
Eventually, as much as picking the right abstractions is important, and like making good calls and finding entropy, eventually we are working with people, with engineers and there's politics, there's like messy interactions.
Yeah, so, I've spent countless hours basically one-on-one with lots of community members and say, look, we need to make that, sorry about this, sorry about that. And I actually went into userland to code mod their code base because it became a skill after that particular React task on the React team. And then you realize, this actually works out. Like you can just like refactor userland code quickly if your community was small. And then when you grow big, you need a different mechanism and all that. But now that you mention entropy control, like OCaml was a great language in terms of entropy, really, right? Because it does do academic stuff, but it does it in like a pragmatic way. Like if you're a language engineer, you look at its GC and how it ties to the languages like polymorphism and all that, and you're like, oh, I guess there's an alternative to Go, and you don't have to not have generics, and it can still work, right? And Go made the right trade-off for what it needs. I still believe that, but it's interesting to see the other way around, and it's also interesting to see how far you can push a GC without needing to realize, oh shit, I guess I do need manual memory management here and there. It's also interesting at the type level to say, oh, hey, I can have this type. It's not going to generalize completely, but it's good enough for daily workload. And that part, the last part of the sentence, the daily workload, is not something an academic language can possibly say if they don't put it in production. The OCaml people did, so they know exactly what good enough is, and that's very important. Some of its type system features too, and I still believe. Nowadays, for some of the work, I do touch TypeScript, right? And having seen the full spectrum of things, and having used ActionScript 3, which was basically TypeScript 20 years ago, 15 years ago or whatever, I still think that we don't need that much of the types. Like if you look at the stuff people write with TypeScript nowadays, it's like they are no longer guided by types, because types was supposed to control your entropy, right? In the very least, by saying this is always going to be an int and not a string, in the very least. Mm-hmm. And it was supposed to exercise this kind of like a slightly top-down skeletal pressure onto your code base, so that you don't do wild shenanigans. But I think TypeScript nowadays, due to popularity, it bends itself over way too much. So it no longer informs how you should be coding, which is what was one thing Reason and ReScript care a lot about, which is telling people, look, I know you want to do this, but trust us, you don't necessarily need this to get an app done. You can use this other pattern and it'll be simpler. It's quicker now and it's quicker later. There are such sweet spots. But TypeScript doesn't teach you that anymore. TypeScript just teaches you, if you want to use that pattern, let's have it dynamic, and I will always be able to bend myself backward to counter that. So when people do that, it becomes like their type, when you hover over it, I see types that are like a page long, right?
Yeah.
And is that really helping you becoming a better engineer? Is that actually good for the code base? No. And people will say yes, because they're like, well, I got stuff done. But they don't know that they could have gotten stuff done better and learn better and more performance simpler for the other people. They don't know that, right? Because the types never told you. The type just told you, this is what that is, and this is that mix. So I think the core difference between TypeScript and a language like Elm, a language like Reason, and a language like one of those compile.js languages that have sound types or whatever, is that like which perspective you come from. And Elm and Reason and ReScript took an intermediate perspective that said, well, you do need these 30 patterns, but hold off these 30 patterns. And that is very powerful. And I do think people learn, even if you only use TypeScript, I think people who use ReScript and Reason understand TypeScript better and understand when not to use certain part of TypeScript thanks to Reason and ReScript, and that's good enough for me.
Right. Tell you the truth, when Reason came to be, I was sure in 2022 we're going to use Reason as the default language.
No, I don't. Yeah, I mean, at least with a vote of support. It's a different thing. Maybe it could have been, but I don't even know if this is necessarily the right thing. That, well, first, it did this role serving as an example of what's possible. That's one thing. The other thing is Reason goes against the JavaScript community. When React was released, it goes along with the JavaScript community because JavaScript community loves new frameworks. And ultimately, it turns out they love syntaxes and all that. Right? We have the syntax part now, but it is fundamentally a language that says you don't need JavaScript. So it's a different kind of dynamic. So I didn't go into that thinking that it'll dominate. I went into that first because I want to ship a good product with it, right? And also because I want to learn, and also I know that was going to be a good thing, and I wanted to share that with the subset of people who did care about that. Whether it takes over the world is of a secondary concern to me. I don't even think, like, nuance doesn't scale, right? Fundamentally, nuance doesn't scale, and good stuff almost doesn't scale always, right? Beside the basic stuff, and I think it's good enough that we had a good stuff, and I speak in past tense, but it's still going, right? Like, people still use it. I don't want to make it sound like it's obsolete or anything like that. Like, ReScript is, it works and it's solid and it's stable. That's like, we don't release something that breaks your code base on like some certain other languages, right? Like, that's very important for a startup, right? You don't have time for that. So it still works, but I think I like the fact that it was more of a good thing that was for a certain subset of people, and you don't have to cater to all sorts of tastes, because otherwise you get a very bland language. You get a language that caters to everyone, which means you cater to nobody, and nobody's happy, right?
Yeah. Markdown wasn't invented to dominate the word. It was invented because it made sense for during Fireball. I don't know the name of the person who created it, but
Gruber.
Yeah,
John Gruber.
Yeah,
very nice.
Sorry.
So
I definitely understand where you're coming from.
Yeah, it's invented for that subset. It's exceeding that subset now, so that's kind of awkward. But yeah, ultimately it was readable ASCII, and that was great, right? It was not meant to be a serialization format like people are dangerously turning this into, and it's a full-blown rich text editing, whatever, like people are also trying to turn this into. But yeah, it's great for what it does.
I would use this pause to just talk a little bit about the sponsor of this talk. So this whole podcast exists because I get the backing of FlyCode, the startup I'm working at. And I will try to tie it in. FlyCode is trying to give less power to product managers and designers in a good way. It allows to edit real things in web apps like text and images and getting them back into the code as pull requests. So even though product managers and designers don't necessarily know what engineers know, they can still affect the product in places that they are comfortable, and they are the source of truth for those apps. So today, if you can connect apps that use React or Vue or Angular, stuff like that, and let product managers and designers and marketing people edit texts, and it gets back into the code as pull requests. So that's just a word about the sponsor of this podcast. And let's dive back into the talk. So we talked a lot about, well, product and thinking about product. And like you said, you started with just wanting to build cool stuff with Flash, and all of a sudden here you are giving 6 years ago a very philosophical talk. And I really don't know the answer for this. So like, this is a personal question. Like, how one get these ideas, these principles, these thinking patterns about software. It could be also for other things, but specifically for software. You mentioned things from Alan Kay and like all kinds of principles like Conway's law. How did you get to learn about those things and like build this ability of like thinking in a more abstract, whole, like broad way?
Because you don't even know if you don't know, right? You don't even know that there's this thing you need to think about. So the first thing I did, well, the first thing wasn't me, it was on my parents, who made a very crazy decision to immigrate from China to Canada, to let me experience a complete different kind of philosophy all the way across the opposite end of the world. That's one thing. And then I made a decision that came naturally to me, that because I had this enriching experience, that I want to move to California and sit right next to the people who made the things I care about. This is 80% of it. It's that simple, but it's also hard to pull off. Understandably, not everybody has the opportunity for that. I mean, I know that we came to Canada with nothing. So, but if you have the opportunity, absolutely go reach out to the people. And Steve Jobs once said that too. Like, if you just ask, you'll be surprised at how generous people are. And so basically I did ask by moving to California, sitting next to people, sitting next to TC39 people, right? Sebastian was on TC39, Jeff was on TC39, and Benjamin was too. Jordan didn't want to be or something. I don't know. But yeah, and sitting next to Paul Tomatino, this was one of the best things I've ever done for my career, right? And they will make you think about the things you didn't even know you should be thinking about. The other thing is that you have to put in the work. People don't like Hacker News for various reasons. They think they're like a little bit of it. I kind of agree, but I read it. I've been reading it for the past almost decade. My recount on Hacker News is around 1 article out of 5. And you can imagine how many, so that's a 6-digit amount of articles, actually. That gives you all sorts of perspective at the end of the day. So you get a very holistic picture. You have to filter it. That's true. But if you do filter, it's like finding treasure sometimes. So practically speaking, these are the two things. The other thing is you have to ship. And I've seen that happen to a lot of people, because you can dwell on an idea for decades, a wrong idea, subjectively, let's just say, a wrong idea for a decade without knowing it's a wrong idea. And lots of people don't want to, because the moment they ship and they realize that idea is not as romantic as they thought it would be, like they can't accept it anymore because it's their baby now and all that. You have to be able to kill these ideas, be able to understand the contrarian perspectives, and ship and validate your ideas. And not just ship, but ship different things. Because it also happens that I've seen in some of my previous companies, people ship a single thing for 10 years and think that's the ground truth because that has worked for 10 years. So they can't actually switch domain and realize that, this is not that true, right, elsewhere, right? And even the basic things are not necessarily, that you take for granted are not necessarily true once you switch domain. I used to, well, let's talk about more of these examples later, but yeah, these are the high level advice I think I can give. And yes, you have to think a lot, do a lot. I forgot who said that too. Like if we go back to the basketball analogy, I think in this industry, especially infra engineer, especially the infra engineers that talk too much on Twitter, they give me this impression that they are sitting on the bench in a basketball game and thinking how to shoot balls. And then they think they know how to shoot balls. No, you learn how to shoot ball by shooting balls, right? Then you get back on the bench and you think about it for the rest of the day. And then you go shoot some more. But unfortunately, they sit on the bench all the time. They have all this time to talk about like what amazing work they can do and all that. And people are like, wow, this is amazing and all that. But they don't know that this person actually doesn't ship or whatever. It just looks like they ship, right? They ship libraries for other people. It looks like they ship, but they don't know if these libraries work out. So you end up having these dynamics in the JavaScript community where some leadership people with large amount of influence, a disproportionate amount of influence, ship library that ultimately actually people don't like these libraries too much, except that one tech lead who wanted to understand that library. So my advice for that also, the reason I talk about this is I think this will actually fix our community too. Our community is great and all that, but we are flawed, and we are flawed in ways that other community criticize. And I think some of these criticisms are right. We need to ship more and ship more of different things, which is what this community lacks. And actually, sometimes go back to the theory, go back to the drawing board, and think, well, does this actually work, or is there a better way to do it? And hopefully, we come back and make this whole UI thing a little bit less ridden with shenanigans.
But going with your basketball analogy, when you are on the bench, like you are shooting basketballs and that's great, but you are on the bench, how do you deepen these understandings? How do you broaden your thought about those ideas?
You talk to the presumably world-class teammate whose team you join, right? Like I said, you talk to them and you're like, did I shoot correctly? Did you shoot correctly? Did we cooperate better? Right? What's your experience here and there? And they'll tell you. And those experiences, they might not actually be always right, because they might also be flawed, right? Like you are, and like me, I am. But they will give you something to think about so that you can explore that space yourself. And they will provide you with that shortcut so that you don't have to go through 20 years of experience to first try something, right? So yeah, you talk to your teammate, and also make sure you're actually playing basketball and not baseball, because
that's always important.
Yeah.
Well, on that happy note, I just really want to say thank you for coming to this podcast, and I'll see you all in the next time of Merge.
Thank you for having me. Have a nice day.